Baby bear to Papa Bear. Baby bear to Papa Bear, do you read? Over.
Papa Bear to Baby Bear, go ahead. Over.
Papa Bear, I'm getting pretty close to the end. Do you still see me? Over.
Baby Bear, I can see you just fine. Continue to your objective. Over.
What are you guys doing?
Mini Believer bet me $20 that he could prove that the Earth is flat.
By rowing a boat?
Yeah, we're recreating this famous experiment where this dude had his buddy row a boat 6 miles down the river to see if his boat disappeared over the horizon. You see, if Mini Believer rows 6 miles away, then I should lose sight of him and his boat because they'll be 16 feet below the horizon.
Papa Bear, my arms are getting tired. Over.
Keep rowing, Baby Bear! This bet was your idea. Over.
This sounds like a good experiment, but it feels like you're missing some variables here.
No way. This is observation. How much more scientific can you get than observation?
I don't know, boss. I'm skeptical.
Yeah, well, Mini Believer is pretty sure. Mini Believer told me that the Earth is flat, and that made me very skeptical.
How far away is he now?
Fucking ask him yourself.
Hey, Mini Believer, where are you? 10-9, say again. Over. Believer, it's me. Where are you? Say again, I'm having trouble reading you. Over.
Dude, this is a really formal experiment. You have to use radio jargon. Start each conversation with your call sign and end it by saying over.
Okay, what's my call sign?
Mama Bear.
Mama Bear, why?
Sorry, man, you weren't here when we chose the call signs.
Jesus, fine. Mama Bear here. Mini Believer, where are you? Say again, who are you calling Mama Bear? Over. Mama Bear to Baby Bear. Where are you? Say again, you broke off. Over. Fucking Baby Bear. I'm fucking Mama Bear. Where are you? Over. Baby Bear to Mama Bear. Are you asking my 20? Over. Baby Bear, for fuck's sake. Yes. What's your fucking 20? Baby Bear to Mama Bear. What's my 20 what? Over. What's your 20? Over. Baby Bear to Papa Bear, come in. Over.
This is Papa Bear. Go ahead. Over.
I've reached my destination. Do you see me? Over.
What the fuck? Baby Bear. I see you. What? I see you. I don't believe it. Over.
And that is why you fail. Over. You two are fucking retarded.
So in my search for some conspiracy level things to debunk, I found this hilarious show. It's called The Late Night Show, hosted by Milenko Nedelkovsky. As far as I can tell, it's Russian. I know some of you are going to tell me it's like Ukrainian or some shit. Anyways, point is, Eastern Europeans love this conspiracy theory stuff. All of the best UFO, flat earth, alternate dimension, government conspiracy theory stuff comes from Eastern Europe. And it seems that this show considers itself an alternate media outlet. And the first guest that I found on this show is a flat earther who goes by the name D. Murphy25. He has his own YouTube channel and says hilarious things like,
what about the people in Australia? They're standing on the bottom of the globe, won't they fall off?
So we're in for quite the ride.
A pilot is flying around the curve of the Earth, then he should be dipping the nose down. Every 5 minutes he should be dipping the nose down to stay around the curve.
Yeah, and who's to say that he's not? Planes have to make constant adjustments to stay level. Between wind, turbulence, and topographical changes, planes are constantly adjusting their pitch.
But the thing that really got me interested was, as you say, the gyroscope. In a plane, there is an artificial horizon, and it's based on a gyroscope. And if you spin a gyroscope on a surface, it will want to stay upright. You can twist and tilt the surface as much as you like. The gyroscope will stay upright. If a plane has a gyroscope and it starts following the curve of the Earth, the gyroscope would stay upright, which means the artificial horizon will start to roll backwards. But it doesn't. That's absolute proof that a plane flies over a flat surface rather than a curved one.
No, you absolute silly goose. Every single gravity, weight, and direction-related argument I hear coming from flat earthers all work off of the same principle. The gravity works in one direction. Gravity on Earth all gets pulled towards the center of the Earth, not straight down in one direction. Yes, if you put a gyroscope or a top spinning on a table and you tilted that table, the gyroscope or the top would stay in the same direction. But that's because gravity doesn't change direction in that circumstance, just the surface that the gyroscope is on. However, if you were to tilt a plane downwards to follow the curvature of the Earth, you're not just changing the surface of the gyroscope traveling across the surface of the Earth, you're also changing the direction that the gravity is coming from. The gyroscope works on a principle where the spin counteracts the force of gravity, so it keeps the top on a particular angle. If a plane were to go straight and slowly fly out of the atmosphere, eventually that gyroscope will change direction so that the top will work perpendicular with the surface. It will be attracted by the gravity of the planet. However, on your model, if the gyroscope were to stay the same while the plane pitched down over the surface of the Earth, what that would suggest is that gravity only works in one direction, and it's not in relation to the Earth at all. But that's not how gravity works. Gravity is a result of Earth. It doesn't work independent of the Earth.
Because I asked the pilot on my last flight, did you ever notice the artificial horizon rolling backwards? He said, no, but the artificial horizon has complex electronics in it to make sure it knows where it is on the Earth and it compensates. But I went to the manufacturer of the artificial horizon and they confirmed to me that it's completely mechanical, nothing electronic in it whatsoever. So it's literally just a gyroscope that can freely move. That right there is proof to me that planes fly over a plane.
That anecdote doesn't make any sense. So you found a pilot who doesn't know how gravity works or his equipment works. That doesn't mean that the fucking planet is flat. I bet you I could find you a race car driver that doesn't know how combustion engines work, but that doesn't mean that fuel isn't flammable.
None of it makes sense. The problem is that we're taught as children this ball earth lie.
Oh, fuck.
You might ask as a child, what about the people in Australia? They're standing on the bottom of the globe, won't they fall off? And your teacher says, no, gravity. And you go, oh, okay. And you never go back to that question.
Yes, because you have a child's mind and children don't understand how gravity works. But then you grow up.
But when you go back to it as an adult and start looking at it with a critical eye, the whole thing falls apart.
Only if you never learn how gravity works.
As you say, the globe is spinning at 1,000 miles an hour. Neil deGrasse Tyson, who's a leading astronomer in America, tells us that the Earth is not a perfect circle. It is actually an oblate spheroid. It's squashed and wider at the equator.
Earth, throughout its life, even when it formed, it was spinning, and it got a little wider at the equator than it does at the poles. So it's not actually a sphere, it's oblate. And officially it's an oblate spheroid. That's what we call it. But not only that, it's slightly wider below the equator than above the equator.
A little chubbier.
A little chubbier.
Yeah.
Chubby's a good way. It's like pear-shaped.
That was it? You're done? Was that supposed to be proof of something? Are you trying to suggest that because the Earth is spinning so quickly that we should be flying off of it? Because you understand that we're spinning that fast too, and relative motion teaches that one force only works on another if the other force isn't already working in that same direction. Yes, the rate in which the Earth spins does have an effect on our bodies, and yes, people who live a little bit closer to the equator are just a little bit lighter than people who live closer to the poles, but the only way that the Earth's spin can counteract gravity to the point where people can get thrown off the planet is if the rate of the spin increases exponentially or if the Earth stops dead, and neither one of those things is likely to happen.
The other thing about the spinning Earth is looking at the stars. Directly above the axis of spin is the pole star, Polaris, directly over the North Pole. And we're told that the reason that all the stars spin around the North Star is because the Earth is spinning at 1,000 miles an hour. Seems to make sense because if you put a long exposure camera pointing at the North Star, you'll see the stars will make perfect circles around, perfect star trails. The only problem is the Earth is also orbiting the Sun at 67,000 miles an hour. The Sun is moving, dragging the Earth and all the planets up that way or that way at 600,000 miles an hour. So why do we see perfect circles? Because that's the slowest speed that the slowest motion in that mix, and yet the Earth is moving 67 times faster that way and 600 times faster that way. So you should see the stars do all sorts of strange motions, but you don't. You only see them make these perfect circles. That tells me that it's the stars that are moving, not the Earth.
Do you have any idea how far away those stars are? This is another one of those things that flat earthers tend to completely throw out of their equations. Polaris, for example, is somewhere between 350 and 450 light years away. They're not entirely sure. The point is, movements of celestial bodies in the sky are all relative to their distance from the Earth. The sun, for example, is so far away that if you walk from one side of the city to the other, you're not going to see the sun move from one side of the sky to the other because the sun is so far away. In that same way, moving a few thousand miles isn't going to change the position of a star in the sky because those stars are so far away. However, if you set up that same camera in the same spot pointing at the same point in the sky every single night for a year, then you're going to start noticing little deviations of where those stars are. One night is simply not long enough to notice the positions of stars great distances away from us changing. From our relative position in space, our spin seems much faster than the change in positions of stars in the distance. It took scientists thousands of years of stargazing to notice that stars actually move in the sky, and hundreds of years more to realize that they're moving a lot faster than the Earth is. I mean, one night is such a short period of time, it's like a photograph in the great span of the infinite universe. It's like looking at a photograph of your mom and saying, oh look, my mom doesn't move because she's not moving in this photograph.
The thing is, what the scientists will give you is calculations and theories why that happens. But we have experience. We see things and they either make sense or they don't make sense. What the scientists do is substitute our common sense and our intuition for calculations and theory, and we're supposed to believe the calculations rather than what we experience ourselves.
Yes, because our observational skills and our intuition are a result of millions of years of evolution. We didn't evolve to understand the universe and physics, we evolved to understand and survive in our environment. It took the development of science, math, physics to better understand how the things around us work, because they are counter to our intuition. For example, it took science to figure out how rainbows work. We didn't realize it was just white light being scattered into several different directions. In fact, the next thing he's about to talk about here is a perfect example of how our senses can fail us in just normal observation.
There was a famous experiment back in the 1800s in England called the Bedford Levels experiment. The Bedford Levels is a canal that is perfectly straight for 6 miles. What a chap called Samuel Rowbotham did was he took a telescope, put it in the water about 8 inches above the water, and he had a friend in a rowboat with a flag on the back row all the way to the other end, and he was able to see the flag on the back of the rowboat the whole distance. According to spherical trigonometry, the curve of the Earth is 8 inches per mile squared. So over 5 miles, that's 5 times 525 times 8, which is 200 inches, which works out at 16 feet. That means the boat should have been 16 feet below the horizon. He shouldn't have been able to see the boat.
The problem is that Samuel Rowbotham's experiment was hardly scientific. He didn't factor in any kind of variables. He didn't set up any kind of measurement tool to prove that the boat was still on the same plane. All he proved is that he could still see the boat, which really tells us very little.
The scientists will say, oh, refraction and this and light bending around the Earth and stuff. But the fact is, it's perfectly flat, and in his book he puts forward many arguments that show, many experiments that show the Earth is always perfectly flat.
Exactly. It's a well-known fact that light only travels in a straight line in a vacuum. You add in any other factors like gases, liquids, gravity, the light is going to change direction, sometimes only slightly and sometimes by a lot. Everybody knows that if you jab a stick into the water, that stick changes direction as soon as it crosses the surface. That's because light is refracting through that water. In the same way that light changes direction in water, it also changes direction in atmospheres. But of course, because an atmosphere is much more diluted than water, the change is much more gradual and slight. We have every reason to believe that Samuel Rowbotham actually knew about light refraction, because that was something that land surveyors would factor into their calculations at the time. In fact, his experiment was set up specifically to capitalize on the way that light refracts. The colder and denser the air, the more it curves downwards. That means something that was, say, 6 miles away, the light from it would curve downwards back towards an observer, making the object appear several feet above where it actually is. A separate man, Alfred Russel Wallace, revisited this experiment but added in a way to measure the difference in an observation as it relates to distance. He set up 3 poles. He set up his telescope at the first pole, the second pole was 3 miles away, and the third pole was 6 miles away. And what he observed was that the pole that was closest to him actually appeared lower down than the pole that was furthest away from him, which appeared to be higher up, which is not only impossible on a round Earth, but is also impossible on a flat Earth. So what this suggests is that light can change direction over great distances. Boom, pwned.
They say that you see the mast go down last. It's literally just the way your vision works. It's perspective and atmospherics.
Correct. It's the way your vision works. It's perspective and atmospherics.
The limit of your vision is supposedly 3 miles. And then after 3 miles, you're supposed to see the boat start to go over the horizon. It's funny that Neil deGrasse Tyson again explains that you can't see the curvature of the Earth from a plane because you're not high enough. The Earth is so big that you can't get high enough to see the curvature. Yet, you can apparently see a boat go over the curvature, over the distance of 3 miles, which doesn't make sense.
Are you fucking kidding me? Yes, you can't see the actual physical curvature, but you witness the effects of it. I can't see London from here because of the fucking curvature, but that doesn't mean I can actually see the what? Is this a serious argument? Remember Lanky Larry, he could only see the horizon. His vision of the sphere was obstructed by the horizon. But if Lanky Larry was even taller, he could see both edges of the ball. And in that way, he could see the curve of the Earth. But somebody else who can see Lanky Larry's left foot may not be able to see his right foot because of the curvature.
The thing is, when you look out and you see a boat start to go over the horizon, if you suddenly get a pair of binoculars and look, it comes back again. And once it goes out of the sight of your binoculars, if you get a telescope, it comes back again. It doesn't go over any curve of the horizon. One of the best examples of that is the Antwerp Notre Dame spire, which can be seen something like 240 kilometers away from the spire. So that should be over a mile below the horizon, and you can still see it. There's a place in Bolivia called Salar de Uyuni, which is a salt flat. It's literally 100 miles wide one way and 80 miles across, and it's perfectly flat. When it rains, you get an inch of water, and it looks like a perfect mirror. How does that happen on a sphere? It shows you that if you're one end of this salt flat, you can see perfectly clearly the other end 100 miles away.
So the reason I left that whole part in there is because it shows every single example he has of the flat Earth being observable is over water. You notice that? Every single time it's over water. These salt flats, if they are as flat as you say, you should be able to observe both ends of the salt flats on a dry day as well. But you can't, because there's no cold water on the surface to refract the light back downwards. If you really wanted to recreate this experiment, you would wait until the salt flats were dry, even wait for a cool day, give yourself the cool factor, set up a post on one end and a telescope on the other, you should be able to see the post. But you can't. It requires cool water to recreate the experiment.
If somebody given the task to mock up the Earth in the moon's sky, you immediately think, well, it should be about the same size as the moon. If you don't think about it, you'd make it the same size. So yeah, it's just a schoolboy mistake.
I'm not entirely sure what he's rambling on about here, but it sounds like what he's saying is if you look at the Earth from the moon, the Earth appears the same size in the sky as the moon does if you look at it from the Earth. And I have no idea where he's fucking getting this from. If you go outside right now and take a photo of the moon with your cell phone all the way zoomed out, the moon's going to look like it's the size of a star. But if you can zoom zoom in to the moon with a telephoto lens, you can make the moon look really, really big. It all depends on the lens and the perspective of the photographer. But I've taken the liberty of pairing up a couple photos here. The first one here is a photo of the Earth as it appears from the orbit of the moon, and the second one here is the moon as it appears from the orbit of the Earth. Now, if you match up the two celestial bodies in the foreground so that they appear the same size, you're going to notice a little bit of a discrepancy in the size of the celestial objects in the distance. However, if you match these two celestial objects up so that they're the proper sizes, relatively, I mean, I didn't measure them, you're going to notice that the celestial objects in the foreground appear much different as it relates to their curvature. The Earth and the moon do not appear the same size in each other's skies. That is just blatantly false.
The other thing is, if you were to go to NASA and download one of their photos of the Earth in the moon's sky and put it in Photoshop, drop the saturation and the levels down, you'll see that the Earth has been pasted in, because you'll see a rectangular box around the Earth. It's all fraud, it's all fake. Pretty much everything NASA puts out is fraudulent.
It would have been great if you could have shown us an example of this, but I'm going to go ahead and believe you that you can find photos of the Earth as taken from the moon and it looks like there's little boxes. Back in the old days of photography, when they would develop photos in a darkroom, they would sometimes draw shadow boxes or place things over top of the paper so that things would develop differently. I'm sure that the Earth would have been very difficult to expose properly on a photograph as taken from the moon, because the moon would have been receiving so much light. The Earth probably would have just shown up as a blurry ball. Now, if you draw a box of shadow over top of the Earth so that the Earth develops slower on the photographic paper, you get more detail in the Earth. All you've really proven with this is that they got lazy, and instead of drawing a circular shadow over top of the Earth, they drew a square one, which proves nothing. I love all these photography questions. I'm such a photography geek.
There are no images of Earth from space. The only one that NASA actually claims is a photograph was from 1972, and it's the famous picture. It's got Africa sort of near the top, and it's the same picture they've been using for the last 40 or 50 years in every textbook. Every other image is what they call a composite. It's Photoshop. And many of us have been looking at these images of Earth, including the one they call the Big Blue Marble, which was released in 2002, I think. Again, when you zoom into it with Photoshop, you'll see where they've used the clone tool in Photoshop to take a picture of one of the clouds and stamp it in various places around the picture. And they got lazy.
What he said here is pretty much true. There are very few photos of the Earth from space, but the one of Africa is not the only one. It's just the most famous and commonly used one. Galileo, which was a space probe, actually took several shots of the Earth as it was leaving, and there are actually several photos of the Earth as taken from the moon, but those are not complete photos. You don't see very much of the Earth, and it's not in very high resolution. Most of the complete photos of the Earth are actually composites that were taken from orbit and then had clouds added to them afterwards. That way they could control the environment and control the weather so that the better features of the planet weren't obscured by clouds. But this isn't done to hide the fact that the Earth is flat. This is done to get the highest quality, highest resolution possible photos of every region on this global photograph. Plus, it's exponentially cheaper to do it from orbit than it is from a probe that's sent away from the Earth. The most detailed and accurate modern photos of the Earth are taken by NASA's Earth Polychromatic Imaging Camera, also known as EPIC. That's right, there are EPIC photos of the Earth, and they're actually composites of only 3 photographs instead of a series of photographs. You can view both of these images on NASA's website, and it seems that they were both taken in July of 2015.
In another image, they've even photoshopped the word sex in the clouds, which is a subliminal tool they use to get people to relate to something. They literally, you can look at this and find it on NASA's website.
Yeah, and that's fucking hilarious. But that doesn't prove that the Earth is flat.
I've got a video from what they call the Galileo space probe. As it left Earth, it took a series of shots of Earth, apparently, and you see that over the course of 25 hours, the clouds never move. I happened to find some satellite pictures of Earth, and I noticed that in these separately taken satellite shots, the clouds were exactly the same as the ones in this Galileo shot. So it's a cloud map.
First of all, those are large weather formations. It takes a long time for large weather formations, especially ones that aren't storms, to travel great distances. For example, the last hurricane to hit the United States, Hurricane Matthew, took a full 30 hours to travel from the bottom of Florida to the top of Florida, and that was a fast-moving storm. And it's really easy to say that you found other photographs where the clouds are in the exact same spots, but without presenting those photographs to us, you're just speaking out of your ass right now.
It would be very simple indeed to just silence everybody and put an end to this topic once and for all, turn the Hubble round and show us Earth in real time, zooming in onto the place so that we can see what's happening at that place, and we know that there is something up there looking down on us from space. But they will not do it. They can't do it. It doesn't exist.
First of all, the Hubble doesn't do video, it only does photo, and Hubble was designed to take photos of things at great distances that are not moving very fast relatively to the distance of Hubble. If Hubble tried to take a photo of the Earth, it would just come out blurry because it's whizzing past the surface of the Earth too quickly. And I remember looking into this a long time ago, trying to find live feeds of things close up on the surface of the Earth, and apparently these kinds of things are covered under national security. As it stands, this is the highest quality photo you can get from space right now because there are laws preventing governments from launching satellites that can take better images. You could topple a government if you can zoom in closer than this. If you can zoom into a person, you could zoom into the thing that they're reading as well. Plus, video is not very easy to get from orbit. I think you're underestimating how quickly satellites actually zoom past the sky. Thank you for watching. If you like what you saw and you'd like to see more Armored Skeptic, please like, comment, and subscribe. If you absolutely love me, you can support me on Patreon, or if you have a passing affection for me, you can buy my merch. Links are in the description.